because I think there's number 3.
I think I got number 3. And possibly number 4, but I think it's either positive 3 or negative 3. I don't know. You tell me.
What'd you get for X or number 3? I got 13 over 3. Brother, what?
So
Mentally, I'm a freshman. Actually, I'm not a freshman. I don't want to go back to freshman. I'm not
Real.
I mean, like, I don't want to go back to that, just like, I'm stuck there.
I'm not stuck there. If anything, I'm stuck in 8th grade.
I'm stuck in 6th grade.
Actually, not 8th grade either. I have no idea what I'm saying.
so X, Y, Z. So ordered pairs always go X, Y, Z.
Oh, I didn't do that, did I?
So
X.
Z is negative 1. Y would be negative 1.
I didn't know if it was negative 3 or not.
It would be negative 3. So negative X equals 3. So X has to equal negative 3.
Yeah, okay.
Because we're not so much worried about what X is, negative X is. We want to know what X is.
Wait, what? You know what? I just think it's 0 on this one. I don't want to do it. I can't do it.
Do we want to look, so out of the 5, do we want to look 3, 4, 5, 11, or 13? 5?
Because I haven't done it.
We won't.
All of them. No, I haven't.
Okay. We'll look at number 5, so we'll look at one of them today. 2x plus y minus z is equal to 9. You need a pen. No. If you need a sheet of paper, I do have some over there. Now, looking at this here, we can eliminate x, y, or z. Now, it doesn't matter which one we do because the top equation does have z by itself, 1 in front of z, so we could use it to eliminate it from the other 2. The middle one does have x by itself, so we can do it, and the top one does have y by itself. So really, there's any of the 3 work. So we can do z.
I don't understand how you can pick one.
So here, so the middle one here, 1's in front of x, yes? I can easily turn that x into 2x or 5x to get them to be the same for them to eliminate out. Now, here, I'm going to change this for a second. Let's say it was plus 3y instead of just y. Y would not be a good choice if this was the setup, because 3y and 6y does work all right. I can get those two to be the same. But trying to make 3y be 7y or 6y to be 7y is not going to be an easy thing, because we're going to have to multiply both equations by a number to get them to be the same. We have to do more than one multiplication. You all see that there. So if it was set up this way, y, I wouldn't even look at trying to eliminate first. Especially since x, I can get that negative x to be 2x and 5x. That's nice. Or we can do the same thing with z. Y is not nice anymore. We remove it as the first choice. So we would look at x or z. That makes sense of why we would pick one over the other. But here, the way it is set up originally, any of them work fine. Some of them, 11 and 13, I would say 13, eliminate y first. Just because how the solutions work out, it's nicer to take it out first. Here, doesn't matter, we can do z. Now the next thing we need to do is pick the equation we're going to remove z from the other 2. So we pick whichever one has z, 1z. So we either take the first one or the third one. Doesn't really matter which. Now the next thing we can do is list the other 2 equations. 2x plus y minus z is equal to 9. Negative x plus 6y plus 2z is equal to negative 17. Now the nice thing is our eliminator equation and the equation on the right, the numbers in front of z match up. Not so much the signs, but we both have 1z in both cases, yes? So I can go on and just put them underneath each other because the number in front of z match up. We can go on and eliminate. Now the question is, are we going to add or subtract? So we look at z, so we have negative z and positive z, yes? So the number in front of one is negative 1, the other one is positive 1. So if we subtract, negative 1 minus positive 1 is negative 2. So we need to add. When the signs are opposite of the one we want to eliminate, we add. If the signs are the same for the one we want to eliminate, we subtract. And we apply that same operation across the board. So that when we're deciding subtract or add, we're looking purely, in this case, at z. Y, x, and our number aren't in our focus. We're looking purely at z. What's going to make it become 0? We want it to go away. So here, our negative z plus z, negative 1 plus 1 is indeed 0. So we're going to add across the board. All of them we're going to be adding. Now, if others cancel out, that's great. If not, that's fine. So the first one we have, 2x plus 5x is 7x. Y plus 7y, 8y. Negative z plus z is indeed 0. Is equal to 9 plus 4, which is 13. All right. Now the other equation, we have 2z, not 1z. So we need the z's to be the same. What do I need to multiply by our 1z to get 2z? 2. Okay. So we're going to multiply this entire equation, 5x plus 7y plus z equal to 4 by 2. Okay. Come on. Let's see. There we go. So 2 times 5x is 10x. 2 times 7y is plus 14y. 2 times z is plus 2z is equal to 4 times 2, which is 8. There we go. Pretty close to lined up. Yes. So if we look at our z's over here, we have positive 2z and positive 2z. 2 minus 2 is 0. So here, we're going to subtract all the way through. Now again, I put the subtraction between each one just as a reminder myself, we're subtracting. Our first one, negative x minus 10x. Negative 1 minus 10 would be negative 11x. 6y minus 14y would be negative 8y. 2z minus 2z is 0, just like we wanted. Negative 17 minus 8, negative 25. Okay. So we got it from 3 equations with 3 variables down to 2 equations with 2 variables, yes? Now we need to pick a variable to eliminate, x or y. One of them's nicer than the other. Why? Because the number in front of y is the same. If one of them's already the same, let's use it. Because if we wanted to use x, I would have to multiply this equation by 11 and this one by 7 to get those to be the same. That's the first number. That's 7 and 11 first are the same. But since y is already the same, no reason to do it that way. Questions on this so far? So we have these lined up, set up, ready to go. Now we need to decide if we're going to add or subtract. If If the signs are opposite, we add 8 plus negative 8. 8 minus 8 is 0, so we would indeed add. Now the first one we're adding 7 plus negative 11. 7x minus 11x is negative 4x. 8y plus negative 8y. 8y minus 8y is 0. 13 plus negative 25 is negative 12. We are down to one equation with one variable. Yes? Solve. We would divide both sides by negative 4 minus x is equal to 3. Now the step is to solve backwards. So all that means is we go back up the page, because at this point we've made it decently far down the page. So I go back up to this part here, because I have two different equations with two variables, yes? Do we now know one of those variables? Yeah. So I can pick one of these two. Left or right? Left. So 7x plus 8y equals 13. Well, 7, we know x is 3. So we'll say 7 times 3 plus 8y is equal to 13. Now, at any point up to now, in all of your math classes, we've only been able to solve for one variable at a time. Hey, it was two unknowns. Now it's only one unknown. We can solve 3 times 7 is plus 8y is equal to 13 minus 21 negative 8. Yes. Negative 1. Now we're only missing what? X. Yes? Now we make it all the way back to the top, because we had 3 equations with 3 variables. We know 2 of them now. Now we just need to pick one of those. I'm going to borrow this sheet again. 2x. Well, x is 3 plus y minus z is equal to 9. I just used the top equation. Doesn't matter which one. Because again, the solution, this point, is where all 3 cross, where all 3 are true. So no matter which one you plug it into, you will get the same value for z. Now at this point here, 2 times 3 is, plus our negative 1 is just minus 1, minus z is equal to 9. 6 minus 1 minus z is equal to 9. Minus 5 from both sides, telling us negative z is equal to 4. Well, it really doesn't matter what negative z is. We want to know what positive z is, yes? So, if negative z is equal to 4, what would we say positive z would be equal to? Negative 4, yeah. Because what we can do is multiply both sides by negative 1, or we can divide both sides by negative 1. It does the same thing. Negative 1 times negative z, a negative times a negative is a positive. 1 times z is just z. 4 times negative 1 is negative 4. So our answer is 3, negative 1, negative 4. You're really going to dislike them at the end of this class period.
Great.
Not in the way that you think. We'll get there. Okay. What we're talking about today are matrices. Matrices is a rectangle arrangement of numbers. The dimensions of a matrix are rows by columns. So the dimensions of a matrix are rows by columns. So here we have 2 rows, 3 columns. So we call the dimensions of this matrix a 2 by 3. Okay. Yes. Now, a matrix derived from a system of linear equations, each written in ordered form. So x, y, z on one side equals a number, is said to be an augmented matrix. So we're just going to take the numbers to write a matrix, okay? Now, you don't have to write this next part because this here is not on your note sheets, and that's fine. Now, if we look at this here, the system of three variable linear equation we have right there. We have x first, y second, z third equals number, yes? The numbers in front of our variable for this first one is 5, positive 5, positive 3, negative 2, 1, yes? Augmented matrix, positive 5, positive 3, negative 2, and 1. Second one, we have positive 1, positive 2, positive 3, negative 1. 1, 2, 3, negative 1. And the last one, we have 3, negative 4, 1, 10. So we're really just taking numbers in front of each variable, putting them there. And we just need to make sure it's in the form of x, y, z. If we don't have z, it's just x, y. Well, let's look at the first one. And I just like the fact that this does not start without the screen. So write an augmented matrix for the system, then state the dimensions. Well, the second equation is x, y equals number, yes? The first one's what? The y and x are switched, yes? So our x is what? Negative 2x. So we'll put it first. Then we have a positive 1y plus y is equal to 1. Now, we didn't have to do anything to the second equation, so I just moved it over so that they are lined up. Questions on what we've done so far? Okay. You're ready to write the augmented matrix. First thing we do, brace. This bracket. Okay? Bracket. So, first row, our number in front of x is the number in front of y, 1, and it equals 1. Bracket. I wait to put the second bracket till after we finish the first one so we make sure we have enough space. That's it. Questions on this so far? Let's go to the second equation. The number in front of x is the number in front of y, and it's equal to almost. State the dimensions. So how many rows does this have? 2 rows. How many columns? 3. So it is a. That's it. We ready? No, we can have whatever dimensions we want. So we can have a 10 by 1. 10 rows, 1 column. So rows, columns are this way here. So rows by columns. So rows go up and down, or kind of we're going down. So list the rows. Rows are really left and right. Columns are technically up, down. Rows, columns. Yep. And really, we can list anything technically as a matrix because the desk arrangements is a matrix in a sense because we do have rows and columns. And we'll get more into especially naming the elements. Each number in a matrix is called an element. All right, let's look at the next one. Okay, are both of the equations in XY form? No, the first one we need 4x plus. I'm just going to rewrite the other one so that they are right next to each other. Going across the top, what are our numbers? 4 for x, 3 for y, 13. Second one, 2, negative 1. What are the dimensions? 2 by 3. 2x, 3.
I feel like this is going to get extremely hard. That's what I'm saying. Like, I feel like it's just like, oh, so easy. Haha.
We're ready for the next part.
Oh, you're at one.
So now we have x, y, z. Now the top equation,
Wait, no, it's 3 by 4.
so the top equation, z is on the wrong side, yes? Okay, so let's write this off to the side. 3x minus 4y, 7 minus 2z. So I need to move the 2z from the right side to the, how can I move it from the right side to the left? We can add 2z. If it was positive, we would subtract 2z. So here, I can add 2z to both sides. Because here, negative 2z plus 2z is 0. And on the right-hand side, we have 3x minus 4y plus 2z is equal to 7. All right? I'm just going to mark it out in the problem and just write it over the top because that's our new equation, yes? Same equation, just written in a different way. All right, we ready to go with the first row. So for our first number, we would have 3, and then negative 4, 2, and 7. Second row, x would be 9, y would be, z would be 0 because there is no z for that equation. If a variable shows up once, we need it to have a number in all 3. Since z showed up once, here it has to be 0. And then it's equal to 3. Last one, x is 2, y is, z is negative 1, and it equals 2. Now how many rows do we have? 3 by 4. 3 rows, 4 columns. That's it. So if we look back at the previous one, did either of the equations have z? No, so there's no reason to put it. Because it has to be shown up once. If one of the equations have z, then they all have to have a value for z. That's why we had to put the 0 in the last one. Does that make sense? Because here, the top one and the bottom one had z, so the middle one has to have a z value. If it shows up in one, it's got to show up in all. Make sense? But since the first one was just x, y, x, y, x, y all the way down, z didn't show up at all. No values of z. And yes, the next one, all 3 equations are in the form x, y, z, yes? We go straight to the augmented matrix. Numbers across the top for our first row. 8, negative 3, 1, 5. Next row, 2, 1, 4, 2. Last row, 9, negative 7, negative 3, negative 6. And our dimensions, 3 by 4. Questions on these here? Do we need to see another of writing a matrix, this augmented matrix or stating the dimension? All right. This, as I said earlier, is why you're going to dislike what we did yesterday. It happens this way every year. Many technological tools have matrix features that you can use to solve systems of linear equations. All we have to do is put it in and then put it in reduced row epsilon form, and it will give you the solution. This here, this matrix is in, see if it'll let me scroll, is in reduced row epsilon form. The way, or reason we call it that is because that is diagonal of 1s. Now, when we put this in, we put x first, y second and z third, and it was set equal to what the equation was equal to, yes? So let's look at the first row. We have x plus 0y plus 0z is equal to negative 1.4. Do we actually write an equation like that? No, we won't write the 0y, 0z. All this is saying what? X is equal to negative 1.4. The second row is telling us y is equal to 5.2 and z is 16. So the solution for this here is negative 1.4, 5.2, and 16. Okay. So, 4 steps. 1, write the augmented matrix. 2, input it into the graphing calculator. 3, use reduced row epsilon form. 4, interpret the results. So, this here is right there, a part of that one. We have the matrix. It is an XY form, XYZ form. So let's write the augmented matrix. Across the top would be 1, 1, 1, 2. 2, 3, 1, 3. And lastly, 1, negative 1, negative 2, negative 6. And it is a 3 by 4. Okay. Now you need the graphing calculator. First step is to turn it on. Okay. Second matrix. So, yeah. Let's run it all the way dead. We'll worry about trashing those in a minute. Yeah. So some of the calculators, they will eventually say low battery. For the most part, ignore it. Ignore it till it won't turn on. Because, again, we're going to go through pretty much every AAA battery I have, so let's run them all the way till they're dead. That's not. Go on and grab a different one. I'll have to figure this out later. So, first thing you want to do, second matrix, second x to the negative 1. Second x to the negative 1. And I want to turn this here. Let's clear this out. Clear. Second x to the negative 1. So, we have this here. Everybody see this? So the next thing you want to do is, I'll take those batteries. Go over to edit. Also, at the bottom of the screen, do you see key history? So it will list the key history. So second, x to the negative 1, and you're going to go over to edit. Did we find this? Question. So you're just a step ahead. So we're there. Okay, did we all get to this here?
Got to edit, yeah.
Hit enter.
Why it looked like that.
So this is matrix A. So second matrix.
So mine looks different than yours.
Yep. and then we go over to edit. We'll stick with A. So hit enter. Mm-hmm. Yep. Yep. Mm-hmm. Yep. Yes. So some of y'all's will look a little different because different people have put matrices in. So it's just whatever the last one was put in. Now the dimensions of our augmented matrix are what? 3 by 4. Yes? So up at the top is the dimension. So we'll say 3, enter, 4, enter. Because after you input each number, hit enter because it will move to the next part. So we should be on the first one. Mine will show the whole matrix. Yours is going to show most. So our augmented matrix, yes. So the first one was 1, 1, 1, 2. So 1, enter. So 1, enter, 1, enter, 1, enter.
Well, I should probably change mine.
Yeah, so we'll change it as we go. So as you type each number in, 2, 2, enter, 3, enter. So, yeah, so the first number in the augmented matrix was,
How do I change the numbers?
so type it.
I tried.
So hit, so let's start all the way over here. So hit 1,
This?
enter,
Oh, and then
1,
Oh,
enter.
I'm literally a little bit slow.
Yeah. So once you type the number, hit enter. So 1 and then 2, enter, 3. So you're going to type the whole thing in. Yep. So then the next one is 2, 3, 1, 3, and the last one is 1, enter, negative 1, enter, negative 2. Once you get the whole thing typed in, second mode, second quit, second mode, or second quit. It's the same set of buttons. Yes, it will take it all away because we need it to go away for now. Second mode, and what it is second quit. Second mode, second quit. Because second, if you see all the blue text above each button, when you hit second, it's going to do that. So the mode button, the blue writing above it is quit. So second mode is second quit. So once you get it typed in, we're going to go second mode to get back here. Yes? Okay, now we put the matrix in. The calculator has that put in. Now we're going to go second matrix. This time we're going to go over to math. All the stuff in math are operations we can do to matrices that the calculator will let us do. First one's determinant, the third one's dimension. So if we do DIM matrix A, it'll tell us the dimensions of matrix A. What we want to find is RREF. So going up or down, find RREF. And once you get it selected, hit enter. And it should look like this here. And we'll do some more. So we are here, yes? Next step. Ready? Second matrix again. So second matrix. This first row lets you recall the matrices. So we put the matrix in which one? A, yes? A is already selected. So we could have other things. But go on and hit enter. So it should say RREF A, yes? And hit enter one more time.
I'm so tired of this.
Y'all get this? Second matrix, and then enter. So second matrix, enter. Enter one more time. Yep, enter one more time. So go second matrix, because we need to recall the matrix. So second matrix one more time. And this first one, we can recall that. So hit enter. One more time.
Enter.
Mm-hmm.
Wait, I pushed enter.
Yeah.
You did something.
So,
You messed up that, buddy.
so 1, 1, 1, 2, 2, 3, 1, 3, 1, negative 1, negative 2,
Not very. You're saying
negative 6. Mm-hmm.
not very good. Never good at using my logic.
Oh, so second matrix, RREF. So
Is this how my parents feel?
REF is a different one. So we want RREF. Yeah.
Now this, I know how to use this all day long.
Yep. Yes. Enter. Oh, sorry. Go over to enter. Or so. Second matrix. So you're close. We want RREF. Enter. Now second matrix. Enter. One more time. Okay. So did everybody get this here? Let's see here. Let's look.
You did it right.
So then, so there's two of them. So enter. Second matrix. Enter. Enter. Mm-hmm. So let's look at matrix A. Enter. 3 by 4. So 1, 1, 1, 2. 2, 3, 1, 3, 1, negative 1, negative 2, negative 6. All right. Was everybody able to get here? The last column. Negative 1, 1, 2. That's X, Y, Z. The first one is the X. Second one's the Y. Third one is the Z. So negative 1, 1, 2. So the solution for this is negative 1, 1.
Oh, wait, that was all that for just that?
Yeah.
What the free?
So that problem we started out the lesson with, we could do this with.
So, clear, right? Clear. Woo!
I guess it gives us the.
So,
I'm gonna have to steal it in a minute, but.
so the,
Do not remember how to do this. $80.
so guys, on the sheet. Mhm. So this right here are the steps.
Oh, okay.
So
Already wrote down all the stuff.
So was the negative 1, 1, 2 the answer?
negative 1, 1, 2, yes. So
I got this now, though.
let's look at this one here. Let's do this again. So the first thing we'll do is write this in an augmented matrix. So 2, 3, negative 1, 15. 3, negative 9, 9, negative 12. 4, negative 3, negative 1, 19. So the first thing we want to do before typing this in is writing this as an augmented matrix. We feel comfortable with that, yes? Okay. When we grab the graphing calculator, first thing we're going to do is second matrix. Second matrix. We're going to go over to edit so that we can put this matrix into A. Now this matrix is still a 3 by 4. But the first row is now 2, 3, negative 1, 15. 3, negative 9, 9, negative 12. 4, no, negative 3, negative 1, 19. Once you get it typed in, second quit. Questions on this so far? So we're all to here, yes? Second quit. Second matrix. and we go over to math. And we're going to go up or down to RREF. Then second matrix, A, enter. So, second matrix.
Oh.
Now go over and go to RREF.
I just did that.
Okay. Now second matrix, A, enter.
Oh, so it's.
You need a matrix there. So second matrix, we need something there. Second matrix, enter. So it's A. We're applying it to A, enter. Yes. So RREF. Second matrix A. So the solution. So second matrix. Once you get the RREF, now we need a matrix. So we need A. So hit enter. Enter. So the solution for this is 5, 1, negative 2. So the solution for this is 5, 1, negative 2. So second matrix, so did you get RREF? So go over 1. Go up or down to RREF. Enter. Second matrix. So now we select the matrix we put it into, which would be A. So go, yep. So A, enter. So just enter. One more time.
Oh my gosh, thank you.
You're welcome. So RREF is just the reduced row epsilon form. So when we have that, we need to put a matrix after. We need to tell the calculator to apply that to this matrix.
I feel bad for the ones that.
This will be posted
I love it.
on YouTube.
By myself.
All right. So
That was full of excitement, and I don't have it.
I'm going to borrow this.
Jennifer,
So the one we started class today with, yes? That took, I think it was 14 minutes. Second matrix. Over to edit. 3 by 4. Oh, wait. Let's see. So I'm just doing the one we've started class with. Because so you remember the problem we started class with, the homework one? Yes?
Wait, does it say?
So we found the answer was what? 3, negative 1,
Now I understand.
negative 4, yes? No?
That was yours.
Okay. 3, negative 1, 4, negative
You
4.
don't have to put that in. You don't have to do that. That's not this.
So the answer would be parentheses 3, comma, negative 1, comma, negative 4.
So basically,
That's the answer.
what's the homework problems?
Huh?
Oh, no, I was just wondering.
Yeah. So the homework, 3 through 8. 3 through 8 is write the augmented matrix, state the dimensions. 11 and 12 are correct the error. There's 2 parts. State what they did wrong, so explain why they didn't get the right answer. And 2, write the correct matrix, because they're asking about the augmented matrix. 13 through 19 odd is solving the system. Okay? Thursday or Friday, one of the 2, I will give you time in class to work on those. Also, with the graphing calculators, I started out last year with 27. I do not know who had them, but 3 of them were down. So if you want to borrow them, these are going to stay here. The ones that you're using today are going to stay the class set because, again, we have enough to do that there. But if you do need to borrow one, ask. I have separate calculators that y'all can borrow.